Okay, so when you look at this activity, it's a calculator activity, so you need to have your graphing calculator. And what we were doing is we were seeing essentially how many M&Ms made a belt line, did the diameter of some various sizes of circles, and then how many filled the circle. And so once we collect that, and I didn't really have the data here, so I'll just make some up just in order to show you kind of how it should work. So we look at that, we have some various size circles. Let's just say it took 2, 3, 4, 5, 6, and 7. And from in class, it was somewhere in this ballpark. I don't quite recall what this was. Let's say 3, 6, 9, 15, 25, 36. And I'll pull up the calculator here. And what we're going to do is we're going to use the stat function. First thing I like to do is I'm going to hit second plus 7, 1, 2, clear the short-term RAM here, get anything out, and settings that might have been input by a prior user. And then I'm going to turn stat plot on because that's what I'm using today. So I hit the second key, and then I go to the y equals stat plot, just enter, and I'm going to turn this on. Now I'm going to go to stat right here, and I want to edit a list. So I enter, and now I'm going to put these two columns right into list 1, list 2. So 2, 3, 4, 5, 6, 7. So we've got those in. I'm going to put these 3, 6, 9, 15, 25, and 36. So we've added all this in. Now we're going to go and we're going to look at how this lays out on a graph. And so if I hit the zoom key, I scroll down here a little bit, and since I've used the stat function, depending upon where these are at, your standard window is 10 by 10. And I'm going to go ahead and fit this. I see that clearly goes outside here. So I'm going to hit 0, or I'm going to hit enter at this point, but I'm going to zoom fit it. Excuse me, zoom stat, that's zoom 9. So it's going to fit it to what I've entered in the stat key. So zoom and then 9. And we see it's right here. And this one looks a little off, so I'm thinking something happened when I input that. Let me go back and double check, and yeah, this one should be 25. Whoops, 25. And then we'll go back to our graph, and there we see. And I see 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and there's my 6 data points that's all been graphed in there. Now on your x-axis down here on the bottom, when I plot this on the paper, I'm just going to go ahead and that's the number of M&Ms. I can label this as M&Ms. Then up here, this M&Ms across. And then up here, we'll put this as fill or M&Ms to fill. And then, depending upon how your data goes, this I can probably just go by 1, 2, 3, 4, 5, 6, 7. And then going up, I don't have a whole lot here, so maybe by like 5s. 5, 10, 15, 20, 25, 30, 35. I could have maybe done by 3s or something, just depends on how high your data goes. And then we'll just plot these. We're just trying to display a representation that we saw in our calculator on this graph here. So I saw one at 2, 3, so somewhere about in there. 3, 6, just above. 4 and 9, that's just under this 10. 5 and 15. 6 and 25. I see it's starting to increase over the same interval at a greater amount. And 7 up at 36. And there should be something similar to this. I don't know that it was these exact values. I just kind of picked kind of just what I could remember from class. And we see that we have this graph. It doesn't certainly appear to be linear. Linear, I should be able to kind of fit this line to these points, or at least come very close. And in fact, this was actually a quadratic relationship. Makes sense. That's the unit we're working on right now. So we'll scroll down here, and what we were asked to do is try to model a real simple quadratic function, y equals kx squared, and we're trying to get that to match as many of these points as I can. So I can go back to my graph, y equals, and I'm just looking for some value times x squared. So I'll just start with maybe like a 3x squared. We'll go back to the graph, and I'll see, whoa, it's way too high there. And this needs to stretch out here a little bit more, so let's try something else. So that was 3x. I don't know, what if I make it bigger? Let's try that. So I'm going to double it and see how that lays. And that actually went steeper. Okay, so now I know I need to go the other way on that. So let's try just 1x squared. And for this one, that's getting closer, but it looks like that's even less. Maybe like 0.5 or 1/2 x squared. Try that. And that lays out a little bit under it. So maybe it's somewhere in between, like a 0.75 x squared, somewhere between the two. And I don't know, that's pretty good for what we're doing right here. You can try and come a little bit closer to it to come up with an equation. But what I ultimately did is y equals 0.75 x squared. And that was simply just an equation that closely resembled, came as close to these points as possible. If I wanted to come up with something that was a little better, we actually have some functions in the calculator here that we talked about in class. I can hit the stat key, right arrow over to the calculate feature set. And let's say this is looking like it's quadratic. So let's try to have the calculator find number 5 here, a quadratic regression function for it. I'll press that. I just go down to calculate. And it's come up with an equation of 1.21 x squared plus it's added in a b value. We were trying to be a little simpler than that. And then it's actually slid the function as well with a plus c. We wanted something really basic here, just some value times x squared. But the calculator came up with a more complex one. We can actually plug it in and see how closely it models it. I'll clear this out. I go back to my y equals. I'm going to hit the bars key. I'm going to go to number 5, the statistics, over to EQ for equations. I want this to plug in the regression equation. And I see it's actually entered that in for me there, so I didn't have to type all of that with all the decimals. I'll graph it again. And this should come pretty close. And you see indeed it does for my data set here. So the benefit of knowing how to use the calculator and do these functions, we kept it simple in just this basic form. And that's the formula that I was able to come up with. Then we go down here, and all we're really asked to do is come up with the radii values. We previously plugged in the diameter, and we should know the relationship between a radius and diameter is 1/2. So I'll go back to my stat because I don't remember what they were. To my list, and what I'll do is I'll just half all of these values. So 2, 3, 4, 5, 6, 7. I'm going to write them right up above. I'm just going to half each one of them. And then the same values down here for the area. 3, 6, 9, 15, 25, 3, 6, 9, 15, 25, 36. And then I'm just going to re-enter this data into my calculator. So all I have to change is this column. So I'm going to say 1, 1.5, 2, 2.5, 3, 3.5. And there we go. So now we're going to go back. I'm going to clear this function out because it should no longer match. I'm going to go zoom 9 again just to get the best window fit. And I see it looks very similar. But I've actually halved all of these x values. So the purpose of this, we scroll down a little bit more, is to try to come up with another equation that best fits that model. It's the same basic form, y equals k times x squared. So this is what I'm trying to fit it to. And I know the last time it was right about 0.75 x squared. So I'm going to start with that again. And I see now that's definitely way under there. So let's go back up. Let's try like 3 maybe. 3x squared. And I see that comes pretty close. Now again, I just made up that data. I didn't actually complete the activity. I just kind of threw numbers in there to show how this is done. So I'll say this was y equals 3 times x squared. Yours should come out perhaps a little better fitting than that. And what we're really trying to recognize here is we were working with a circle. Give you a better one than that here. And what we were first doing was finding the number of M&Ms that came across it, and all various sizes, that's the diameter. And then we were looking at how many M&Ms it took to just fill it up. That's the area. And we should know that what we have there is a relationship between, especially the radius here. The area is equal to pi times r squared. Then the area in this case was actually these values down here that were there previously. And then the r number is the radius here. And so we were taking that value and squaring it and multiplying. So the relationship that it was really trying to get us to recognize was between pi here and what we were able to come up with here for our approximate line of best fit, or our equation that modeled those points. And we should see, since you've actually completed the activity, that it should be very close to the value of pi, which we tend to approximate as 3.14. And so just kind of an activity there that can be expressed out as a simple form quadratic, and displays the relationship there again between the diameter, radius, and the area of the circle, and the relationship with pi. So if you have any further questions, just come see me on Monday, and we'll get this wrapped up. Have a great weekend.